Dr. Coskren from Montgomery College here to look at the geology at Conowingo Dam on the Susquehanna River on the border between Cecil and Harford counties. There are interesting geological features at three geological time scales here. The first one is a very short time scale which has to do with Conowingo Dam itself, which is immediately behind me on the river. It's very difficult to miss from this location. The interesting geological feature here is that the dam itself is impounding about 200 million tons of silt and clay that have been washed into the river from upstream. Now this creates two problems. One, the capacity of the reservoir to hold the silt is about 225 million tons, which means it's going on 9/10 filled. And once it's filled, it will not have any more capacity to impound water. And any floods that come in will not be held back by the dam. They'll go right over the dam and downstream. Related to that is the fact that 200 million tons of silt and clay is contaminated by heavy metals and chemicals. And if it is released, or if more of it comes in and cannot be held, it will be washed downstream into Chesapeake Bay, where it will not be at all good for the marine life of Chesapeake Bay. Read for that oysters and crabs, not to mention fish. Something is going to have to be done if this is to be avoided. If you like crabs or if you like oysters, that's why you would want to stop this. If you don't give a damn about the bay, the clams, or the oysters, then don't worry about it. However, the economy of Maryland is in part dependent on those things. So that is the short-term geology here. Medium-term geology, that goes back to the Ice Age. If you see the hills over there in the background of the dam, this dam was put here because it's a fairly deep and narrow gorge. Just like the gorge of the Potomac River down north, west of Washington, and just like the gorge of other rivers that come into the bay. As they leave the Piedmont, they have cut sharp gorges. The reason they did that is because during the glacial period, which started a couple of million years ago, sea level dropped several hundred feet, 200 to 300 feet, depending on the amount of ice that was held back in the ice caps. And when sea level fell by those hundreds of feet, the streams were able to cut down into the rock. And this is the gorge that was cut during the Ice Age. The long-term geological picture here is the rocks themselves. The rocks themselves are what is called a diamictite, which is a giant conglomerate which elsewhere contains pieces of, say, half a mile across. They can be mapped individually. So it's really a very giant conglomerate. Now, that is of some interest because the east coast of North America at that time, half a billion years ago, was entirely quiet with nothing interesting going on. Very much like the Gulf Coast or the Atlantic coastal plain today. So why were these rocks so badly disturbed that chunks of rock that big were falling off and dropping into the sediment? That's because this was not part of North America. There was an entire ocean on the other side here to the west. And during the Paleozoic era, that is between 500 million years ago and 250 million years ago, that ocean was gradually closed until it finally collided with North America. That collision took place in stages, and each time something hit North America, the mountains went up a little bit further. At the end of it, 250 million years ago, Africa itself banged into North America, or Europe further to the north, and raised a mountain range that was almost certainly equivalent to the Himalaya mountains today, where exactly the same thing is going on. India is colliding with Asia, and that's the comparable thing today. The evidence for that is the rocks that contain evidence of this very bad disturbance, rust faulting, pieces, big pieces breaking off, and that is not what you get on the Texas coast today, which is a quiet coast, and that's what North America was like then. We know North America was like that because in western Maryland you find rocks of just this age, and there is no disturbance going on whatsoever. It's nice and quiet. You get clay. You get nice sand beaches. Gulf Coast. This does not belong to that. The bedrock here, called the Wissahickon diamictite. Wissahickon is an obsolete name, so it probably should have another name, but the name doesn't really matter. Diamictite does. A diamictite is a giant conglomerate. This doesn't show the giant part of it here, but you can see there's a big piece right here, there's another small piece right here, and the rock itself is very coarse-grained. It's an extremely coarse-grained sandstone or conglomerate that was dumped quickly from an overlying piece of rock that was being pushed up and over. Rocks like this are found up and down the east coast, right very close to the coast, which is that area that was not part of North America. It was on the other side of that now vanished ocean, which, by the way, was called the Iapetus Ocean. Iapetus being the father of the Greek Titan Atlas, after whom the Atlantic Ocean was named. So it's entirely reasonable. This is the ocean that came before the Atlantic.